So as we get started today, if you have questions, feel free to ask questions in the chat. I will take a look from time to time and try to address the questions as they come in. If we don't get to your question, feel free to hit me up directly. I'm Jonathan Sabo. I'm a solutions architect at Tigera. You can hit me up on Twitter at Jonathan Sabo or LinkedIn if you prefer. Today, we're going to be talking about self-service network security for Kubernetes. So let's dig in. So for an agenda, what we're going to do is just do a quick intro into Project Calico, how to contribute, how to join in on the community, how to stay updated on the latest, greatest Project Calico software releases, and generally just take part in the community around Project Calico. And then we're going to talk about self-service network security for Kubernetes. Just do a little bit of overview, kind of assess the situation, and kind of describe the current state of affairs, some challenges, and then some potential solutions. And then we will start, we'll do a little bit of a live demo. We'll do it live. And then we'll have some time at the end for some Q&A. And I'll take a look at the questions in the chat. And we'll see if we can answer any outstanding questions that happen to come up during the training here today. So hopefully most of you are familiar with Project Calico, but Project Calico, if you're not, it's a community of it's the community that develops and maintains Calico. Calico is the open source network security solution for containers, virtual machines, and host-based workloads. Tigera is the company behind Project Calico. Project Calico, it gives you the ability to enable connectivity for containerized workloads inside your Kubernetes clusters. It's massively scalable. We have many clusters deployed with thousands of nodes, lots of different clusters. We are pretty much the industry standard for network policy, probably the most widely deployed CNI out there. A lot of well-known names that you'll see here in just a bit are trusting us to run their containerized workloads on their Kubernetes clusters on-prem or in some of the public clouds across Azure, AWS, Google. Today, Calico is installed on over 150,000 known clusters. So it's just widely deployed, widely tested. A large community of developers and operators all participating to achieve the Kubernetes goodness and secure network security. Project Calico, we're located at projectcalico.org. You can also hit us up on Twitter at Project Calico. If you want to take part in the community and you're a developer and you want to contribute back to Project Calico, we have our project, our code is up on GitHub. There's currently over 150 plus contributors who've contributed to the community, giving back to the project. If you're looking for some question answers, some help from time to time, or want to just kind of participate or just kind of listen in and see what other people are doing, please join us on our Slack. We have the Calico user Slack, slack.projectcalico.org. You'll be amongst 4,000 other Kubernetes operators utilizing Project Calico. We also have a Discord server as well. Most of our engineers tend to, when they're not busy coding, they're lurking amongst the Slack. So I would suggest joining the Slack. If you have a question, feel free to join one of the channels. They're kind of organized in a topical manner. It'll be obvious. Feel free to let us know that you've joined, that you enjoyed the trainings. If you have any feedback, we're definitely interested in hearing more about that. Calico is as you saw a second ago, it's very widely deployed. It's on over 150,000 known clusters, and of those clusters, it's over 1 million nodes powered by Calico every day. Tigera is the company behind Project Calico. We are the inventor and maintainer of Project Calico. We also, you might not know, co-led the Istio security working group, and we've contributed back to Istio. We have some integrations with Istio and Envoy. Calico Enterprise is our enterprise product built on top of Project Calico. We have a number of customers. Some of them are shown here in this customer slide, but just to show you, we're trusted by top global enterprises. Really, anywhere that network security is a concern. Obviously, the banks and the financial organization, but also healthcare. And other companies. But in addition to that, lots of startups and smaller SaaSes, larger SaaSes. Pretty much it runs the gamut. It's always interesting to see who's using Kubernetes and to see the how widespread the deployment of Kubernetes has become. Today, we are going to talk about self-service network security for Kubernetes. So the situation that we see people sometimes starting out in is they have a centralized policy creation process, and it slows down the ability for teams to collaborate on network policy. Teams that are already relying on Kubernetes to enable agility and the speed of application deployment. They're creating new apps and new services. And as you're creating these new apps, or you're connecting apps and services to existing apps, typically that's going to require network policy rule changes. As teams get going with Kubernetes, they need to be able to secure the applications inside of the cluster. They need to be able to protect the cluster to make sure that the communication required for the cluster operation is secured. And be able to set up guardrails around maintaining availability. And then the security teams will want to the security teams and compliance teams will have opinions on connectivity and being able to implement the safeguards that they're been using inside of the data centers or been implementing inside of the cloud, and we want to be able to apply those policies in Calico policy inside of Kubernetes. The situation we run into sometimes is that the collaboration on the network policies becomes a little brittle and a little difficult to do. And one of the situations that will happen is they'll resort back to this model of filling out a change request for a policy creation. It's a centralized process, and it creates this bottleneck, the centralized management of security policy, network security policy that secures the workloads inside of the clusters. And what happens is it slows down the application development. So you create this cluster, you enable developers to easily deploy and scale and monitor and manage their applications. And then you have these security requirements that require you to segment workloads from one another. And then we bolt on this process that kind of invalidates or slows down the development teams from using the system that is designed in the name of security, because for good reason, that we want to make sure that we aren't putting the cluster at risk, and we want to make sure that we're not putting the organization that's running the cluster at risk. We have to be able to account for compliance criteria and just generally best practices around network security. Like typically a least privilege policy. Applications that are deployed to Kubernetes, we want to be able to move fast, but we also want to make sure that we're not opening ourselves up for attack, making ourselves vulnerable, or potentially putting the cluster at risk from just mistakes, just user error. And so when we try to address those risks and mitigate that, sometimes what will happen is teams will kind of slow things down and say, hey, we're just going to centralize the approval of these policies. And it kind of negates some of the value that Kubernetes gives you. So what do we want to be able to fix that situation? And the challenge is we want to be able to remove that bottleneck. Existing policy change processes, it can be lengthy and complex. So almost the worst case scenario is when we revert back to this ticket-based change management. Requests are made via change tickets filled out by a central policy team. You have a change control board that meets like once a week. The request is reviewed, approved, and then someone without probably the context around the change, the microservice that you happen to be trying to deploy or trying to wire up with existing shared services inside of your cluster. Somebody implements this. And this can take a long time. I mean, I'm sure I'm not the only one on this call that has lived the life of opening firewall request tickets, waiting a while, only to find out that there was some things that were missed, and then having to go through that process again, taking it to 2 to 3 weeks worth of time. So we want a way to streamline this policy and to create a process that gives these teams greater control and removes this bottleneck. And so we want to empower teams with self-sufficiency. We want to create, instead of a centralized management of Kubernetes network policy and Calico network policy, we want to make it easy to manage, and we want to make it safe to manage, and we want to share and be able to collaborate across the different stakeholders that exist. We typically find we have networking teams that are involved in the network connectivity of the Kubernetes cluster. Maybe you're actually even integrated into the top of rack switches in your on-prem cluster. Your Kubernetes cluster is exposing the pod IPs across the greater network and the services across the greater network. So the networking team is involved, and the development teams are rocking and rolling, and they're creating microservices and they're deploying into the cluster. And it's time to start to move into staging or into production. And the security teams are involved, and they're taking a look at the cluster, and they're saying, hey, these protections that we had outside of the cluster in our data center or inside of our cloud, we have all these controls in place. And now these controls, they just don't have the ability to enforce the security controls inside of the cluster. Maybe the network control devices just don't have any visibility into the private network at all. Or the different techniques that people have used in the past just don't apply, or they don't scale, or they don't work well inside of the cluster. And that's where Calico Network Policy really shines. Calico Network Policy, you can use it to enforce network security policy across clusters on-prem or in the cloud. It's the same policy model that is used across the different environments, whether it's on-prem, Google, AWS. You can create standardized policy templates that will allow you to get your teams, your app teams, autonomy. You can create a standard for your app team to get up and running in their namespace or their groups of namespaces. And then with Calico Enterprise, we have a capability that enables to have that policy be applied in a hierarchical manner. And you can create tiers of policy enforcement, and you can protect that the tiered architecture using RBAC. So you can create a policy hierarchy, and you can say, hey, the security teams can apply policy to this tier. The platform team can apply policy to the platform team tier, and the developers can apply policy to their own tiers. And you can restrict who can affect change at those different levels with RBAC. And what that does is it enables teams to be able to collaborate securely and safely on network policy. And we'll see some of that here in just a moment. We also have the ability to provide recommendations if the team's not sure which policy to apply. So coming up with a standard policy template is definitely helpful, but if you even if you haven't done that, Calico Enterprise has the ability to take a look at the communication required for an application and to recommend to your developers a very good starting point for achieving a least privilege policy, network security, Calico policy for your different microservices. We also can enable policies to be tested before they're applied, kind of a try before you buy. We support pre-production staging to audit policy enforcement. So you've either created the standard policy template and you're about to apply it to your workload, or you're using policy recommendations, and you can stage it and you can see, hey, what is this policy going to do to the communication of this microservice? Is this going to drop traffic? Is this going to create an outage? Is this going to potentially put expose our applications to connections that we don't want them to be exposed to? So we can take a look at policy in a staging, as a stage network policy, and look and see, what is this going to do before I start to enforce it? We also capture the flow logs for all of the communication inside of the cluster or specific namespaces inside of the cluster. And that's useful for troubleshooting connectivity issues. One of the first things that I did in a past life was to centralize logging of all my cloud instances, and then to send them to a central SIM, something like a Splunk or another tool like that. And then you can give developers access to those user interfaces, like an Elastic or a Kibana, and then they can troubleshoot the connectivity without needing to come over to the DevOps chair or the DevOps team or the DevOps Slack channel and say, hey, can you tell me why my application is not working? You can empower developers and team members to be self-sufficient and to troubleshoot their own network security controls in their own applications. So I just want to start off with a bit of a customer story. One of the customers that we have recently has started to build out this platform on-prem, and they're moving more and more applications onto this platform. They have a lot of different clusters. They have many clusters, and they're also deployed on-prem and in the cloud and in a couple of clouds. They have large clusters. They have thousands of nodes, and they have a ton of developers. And what I found interesting is that they have a very small Kubernetes operations team compared to the amount of developers that they're supporting. It's literally a give or take a 251 dev to ops ratio. In a past life, I worked at, I supported a very large global mission critical service for the internet, just managing .com and .net. And I was very proud of the fact that it was like a 10-to-1 human to physical server ratio. But now with these shared platforms, utilizing these self-service systems and being able to define things in code and manage things in a self-sufficient way, you can kind of give an individual operator superpowers by creating these workflows and enabling the collaboration, asynchronous collaboration amongst teams, to be able to speed up development, to be able to increase the rate of experimentation, to create to increase the rate of ideation, and be able to more robustly and more quickly deliver contributions to your platform. And just one of the quotes it was interesting to me is that we literally cannot be in the middle. At this scale, we need to enable our developers to safely manage network policy for their applications. It's just not realistic for a team with 10 to 20 people to be able to facilitate like ticket management and change requests for such a large development organization, or many organizations that are utilizing this platform as they go forward and continue to migrate applications to Kubernetes. I wanted to also, just one other customer story, because I had some comments from other people that I've talked to when they see the customer slide. And one of the comments was like, hey, we have the same security requirements as some of these large banks that you have on the customer slide, but we don't have all the resources required. We don't have a 100 member ops team to be able to manage a tool that is very complicated or requires a lot of care and feeding. And Calico Enterprise kind of delivers in both of these areas. We provide you a network policy workflow that will enable your teams to work together autonomously, and that scales even from a small few node cluster with a couple of people managing it, all the way up to the example we just saw with a small team managing a platform for a ridiculous amount of developers. So the network policy workflow enables you to create to kind of free teams to work independently and collaborate together to create network policies, either using a GUI tool or using things like VS Code. If you happen to be a network policy expert and you're familiar with the syntax, you're absolutely able to create things in code and apply them to your cluster. But if you're not, we enable you to manage network policy using a GUI. And if you haven't created any network policies, if you're starting off with no network policies at all, we have some capabilities that can generate the network policies for you based on the observed behavior of the workloads inside of your cluster. And then once you're ready to actually apply policy, you can stage it. You can run policy in an audit mode without enforcing it. And this it lets you identify whether the policy does what it's intended to do. Maybe you missed a couple of some communication that's required for this application to be able to run. If you stage it, you'll see, hey, why am I dropping traffic? Why is this policy? Should I enforce it? Why would it be denying access to the shared logging service? Or maybe this external API that this microservice needs to connect to. So it lets you, sets up guardrails. So it gives you the ability to automatically create these policies, to stage them, and then to enforce them when you're ready to commit the policy to begin enforcement. And then as the network policy lifecycle management, you're going to change policies over time. You're going to create new versions of microservices. They might need to talk to other microservices that you have deployed in a particular cluster, or a service that's in outside of a cluster, maybe a legacy system. Things are going to continuously change. I think we're all kind of aware that we're going to be continuously deploying to our cluster and updating the policy. And Calico Enterprise will allow you to preview the effects of a policy change as you manage the life cycle of network policies that are securing these microservices running inside of your Kubernetes cluster. So you can run policy. You can run policy changes in an audit mode, and then when you want to decommission a microservice, or you want to be able to get rid of access that's allowing access to a particular microservice or something from outside of the cluster, you can preview the effects before you delete a policy. I mean, I used to work in a data center, and I would come in and when I first started, I looked and you see all these network cables, and they're just everywhere. And you're just thinking to yourself, how does anyone know what any of these things actually connect to? And then what I saw actually is we didn't actually ever disconnect anything. They would never pull the cables. They would just run new ones. We give you the visibility to be able to do better than that. We can show you what would happen should you choose to remove this particular network policy. So you have the ability to gain visibility into the change management and see what's going to happen before you actually pull the trigger. So I want to talk a little bit about the self-service building blocks. I think that most of us are probably aware at this point that achieving self-service and enabling developers and teams to collaborate, we're all aware that defining infrastructure as code policy as code, and then using RBAC to secure who can affect change to the policy as code or the infrastructure as code, gets us pretty far down the line of like getting to a self-sufficient manner. We're creating, we're using Terraform, we're using CloudFormation, we're using Autonomy, we're using Azure ARM templates, and we're taking that declarative representation of our cloud infrastructure or our configuration management, or even the build specification for the applications that we're deploying, and we're having that's in code, and it's sitting in a repo, a revision control repo, and we're enabling teams to collaborate, and to, instead of opening tickets and saying, hey, can you make this change, someone can send a pull request. They can send you the change, and then it can be reviewed. The stakeholders can look at the code and they can sign off on it and collaborate it as code, and then promote those changes. So so beyond policy as code in RBAC, there's some other capabilities that Calico Enterprise gives you that I just want to talk about briefly. First, the Calico Enterprise API. What this allows us to do is to be able to use standard tooling like kubectl to be able to manage some of the Calico Enterprise custom resources. It also opens up the ability to use things like OPA and the OPA gatekeeper to be able to, an OPA policy agent, to be able to use like admission control inside of your cluster, to be able to say, hey, we want to enforce a standard label convention across all of our policies, across our namespaces and things like that. If you're doing that with Calico custom resources, you'll need the Calico Enterprise API, and that will facilitate the ability to use things like OPA Gatekeeper. And one of the other interesting things is being able to just even get feedback. Like earlier on, people who use the term shift left, being able to give developers feedback earlier on in the stage, so they know ahead of time, hey, this contribution I'm about to submit, to propose to my network policy, is this in compliance with our organizational standards and our compliance requirements? We have Calico Enterprise flow and audit logs. So we could easily achieve self-sufficiency. We just create one account, we give it cluster admin, and everyone uses it. That would be a terrible idea, right? So one of the important things we need to do is like, hey, what is happening in the cluster? Who's making changes? When are they making them? And what did they change? Calico Enterprise audit logs will show you that. So as teams are collaborating on network policy, you can see on a per policy basis, and also a cluster-wide basis, a cluster-wide view, all of the changes that are happening inside of your cluster. We also show you all the communication across all of the microservices running inside of the cluster. If you deploy workloads inside of the cluster, you'll be able to see all of the communication in using Calico Enterprise flow logs. Calico Enterprise flow logs, they have 25 to 26 different pieces of metadata infused. So they give you the standard 5 tuple flow logs, the source IP, the destination IP, the source port, the destination port, the protocol number, but they also give you the source namespace, the destination namespace, the labels applied to the source and destination. And these are the things that you're going to be using to control who can talk to who inside of your cluster. As you make changes, we can actually preview the policy. We can do policy preview. We can show you using our flow log visualizer, hey, what flows are going to be impacted by this change. As I mentioned before, we can actually look at the flows inside of your cluster built on top of the Calico Enterprise flow logs, and we can recommend to you, based on the observed behavior of your applications, a least privilege policy that you can take and you can stage. And so you can see, hey, what if I was to enforce this policy, what would this look like? And then as we create separation of concerns, separation of duties, we can create a policy model using policy tiers that align to your organizational structure or lines of business. And we'll see how that comes into play in just a moment. So with Calico Enterprise, DevOps teams, they achieve autonomy with a self-service policy creation framework. We give you the building blocks to create a framework that makes sense for your organization. And the intention is to mitigate risk, to create enterprise guardrails around collaboration on the security of the workloads inside of your cluster, and to be able to make that as frictionless as possible. The policy creation process, it's intended to be decentralized within the Kubernetes environment. And the goal is to remove that centralized bottleneck inside of your CI/CD pipeline to eliminate that and to accelerate application deployment. So in summary, Calico Enterprise is going to empower DevOps, it's going to enable self-service, and it's going to allow you to create network policy workflows that make sense for your organization. It is going to give you the ability to free up resources to go and do other things. Developers aren't going to be waiting around for a centralized team to be able to make change to the security controls inside of the cluster. All right, so we're going to get into the demo, but before I do, let me take a look here real quick at the questions. Are you going to share the presentation slides? Yes, we will. At the end of the presentation, later on today, they will be emailing everybody on the call with a copy of the slides, I believe, and probably also a link to the YouTube video after this demo is over. We'll edit up the video, we'll upload it to the Tigera YouTube channel, and we'll email you out the link. We also have a Project Calico YouTube channel as well, and there's some really good videos out there around everything you need to know about Kubernetes networking in AWS, GCP, and also Azure, and some other videos that describe services networking and also ingress. Let's take a look and see here. So a couple more questions coming in. So, hi, what is the Calico Enterprise licensing model and indicative pricing for that model per node, $500 per node? It's definitely, I believe it's a per node pricing for Calico Enterprise. I could definitely have somebody reach out to you to further discuss that with you later. I'm more on the technical side. Do you have any designs around federated policy management or centralized policy across clusters? We do. We have, I actually did a talk a week or two ago around federated services. And we do have some federated policy capabilities. You can check those out in our docs. We also touch on those in some other training scenarios. All right. So we're going to get into the demo. Just to kind of set the stage here. Inside of, I've got a couple of different clusters. So I have a couple of different clusters, and one of them is running this demo scenario. It's just a typical three-tiered application you might see implementing a front-end service that is powered by a couple of different microservices, and then you have like a back-end database. And then there's a shared logging service. One of the microservices has to communicate outbound outside of the cluster to a shared API, Twilio specifically. And so the takeaway here really is that we've got a couple of different microservices that are deployed. They communicate amongst each other to provide a service. And we're going to look at how we achieve self-service network security. How can we create some guardrails that allow us to safely share the fun of managing the network security for our microservices? So this is the Calico Enterprise Manager UI. And so what we're looking right here, this is just the overall stats dashboard. You can see right now we have total policy 0. So right now, everything inside of this cluster can talk to everything else that's deployed deployed inside of this cluster. There's nothing preventing, there's no network security policies that are segmenting any of the workloads. You can see that there's no denied bytes, no denied packets, and you can see that the packets by policy histogram, it's not showing anything because we don't have any policies yet. You can see that we've got some endpoints here. If we filter by namespace, You can see I have this the storefront namespace. This is where I've deployed my demo scenario inside of the storefront namespace. I've got a backend microservice, the front end, the logging microservice, and then I've got two microservice 1 and 2. These are the APIs that are have implemented the business logic of this particular application. If I come over here, let's just take a look. Control get pods -n storefront. All right, just want to validate that I can talk to the cluster and that the UI is showing me we have deployed. All right, so let's come back over here. Let's take a look at these policies. All right, so we don't have any policies. Right now, everything can talk to everything inside of this cluster. And so me as a user of Calico Enterprise, I want to point out a couple of different capabilities here. Just the obvious, we have a GUI. We have the ability to create policy using a user interface. And we can create policy, and we can create policy for the entire cluster. If I happen to be like a security team and I wanted to create general rules for the entire cluster, or if I happen to be a platform team that wanted to create general rules for a particular cluster, I could go ahead and create rules. We can also create rules that are scoped to a particular namespace. And we can target workloads using label selectors. And we can select workloads using label selectors that are applied to pods. So the workloads running inside of our cluster, namespaces, the namespaces that our workloads are running inside of, and also service accounts that happen to be inside of a particular namespace. So we can apply. So you can create label taxonomies to categorize the workloads inside of your cluster, and then target those specific workloads and apply policy to them and govern who is allowed to talk to who using different protocols, TCP, UDP, ICMP, and you see that there's a lot of options, and it can get pretty complicated. So you can imagine trying to bring on new teams and try to ramp them up on collaborating with you via network policy. Being able to do that via GUI is going to take you really far down the road as far as enabling teams who maybe not be familiar with Kubernetes network policy, who have never had to or have no experience with like firewalls or network security controls, and being able to create policy using a graphical user interface. I'm just going to cancel this. So we can create policies using a GUI. We can also recommend to you policies based on the communication inside of the cluster. So let's take a look at one of the other capabilities in Calico Enterprise. This is the Calico Enterprise flow visualization. And what I'm going to do is I'm going to take a look at all the flows inside of my storefront namespace. I'm just going to mouse over these. So I can see that the microservice 2 workload that's running inside the cluster, it needs to talk to core DNS. I can see microservice 1 also needs to talk to core DNS. The front end talks to core DNS. So my microservices are all doing DNS lookups. The microservice 2 is talking to the back end. And you can see over here on the menu on the right, you can see those 2 green arrows. That means that the egress and ingress on the other side are both green. That means that ingress and egress are both being allowed. As I mouse over, you can see microservice 1 is talking to the back end. You can see that the back end is talking to the logging service. You can see that the front end is talking to DNS. You can see the front end is talking to microservice 2. So you can just quickly get a general idea of this. So, hey, I'm a developer. I've deployed my application, and or I'm an operations team that's taken the work of a development team, and I've deployed their application, and I can know very easily, graphically, visually, what is talking to what inside of this cluster. In a past life, I would, in a less agile environment, I would be giving a Word document with like a bill of materials, and it would say, hey, this application talks to this application on this port. And sometimes those Word docs weren't 100% accurate. And so you can see the live connectivity required for this particular application. And you can see it visually. We also give you the ability to look at our Tigera Secure flow logs. I just want to quickly show you here. So here's an example of a flow we saw visually here. This is microservice 2 talking in the storefront namespace to the backend namespace. And you can see here the destination that we're talking to. This is the backend workload, and it has these labels applied to it. It's got at backend, firewall zone restricted, and you can see over here the source. The source has the source is Microsoft 2 in the storefront namespace, and it has at Microsoft 2, and it has firewall zone trusted. And so these are the labels that we can use to create segmentation patterns that we can create templates of these, and we can empower teams to standardize these. And you can see that we've got a list of policies that are being applied to this flow. So you can see that Calico Enterprise is recording all the communication inside of the cluster. It's managing, it's monitoring all the flows. And so we can take that data and we can use that to recommend to you a least privilege policy. So I can come and look at the storefront namespace, and I can look at all of the workflows that I have inside of this namespace. And let me just select the front end. And so I can recommend, based on the observed communication, what is a least privilege policy? So let's take a look at it. It gave us the name, a little randomly generated name, and it's set up to be staged, which we'll see in a second. It's scoped to the storefront namespace. It applies to the workloads at front end, firewall zone equals DMZ. And what it's going to do, it's going to allow egress, it's going to create egress rules for this policy. It looks like the front end is communicating to the logging service, to endpoints that have the label app equals logging. It's also communicating over TCP and port 8080 to apps with the label microservice 1 and 2 in the firewall zone trusted. And so the trusted, restricted, DMZ, this is a paradigm, this is a pattern that you might see outside of your data center, a zone-based architecture. It's just an example segmentation pattern that you could choose as a template to get up and running inside of your namespaces. And you can see it's also letting us do UDP to the DNS, the in-cluster DNS server here as well. And so what we can do is we can preview it, but we can also stage it and we can enforce it. And so we could go right into and enforce, but let's stage the policy. And then you can see in just a moment, we should get some visibility into this particular policy. You can see it's applying to one endpoint. And then in a second, we'll see whether or not we're allowing or denying traffic. While I wait for the stats update, I'm gonna take a look at the questions. How do I get trained on Calico? We have training programs. We'd be happy to reach out to you on that. I believe it's all available on our website. If you go to tigera.io, it should be right front and center how to get supported by our company and how to sign up for trainings. We also do free trainings. If you look at our events calendar, you can see all the free trainings. So would you recommend implementing Calico when you first build your cluster? Is it a significant disruption to add it later? Linked to that, how easy is it to change from Calico Enterprise to Calico open source? Or from Calico open source to Calico Enterprise. We have an operator-based install, and the upgrade, I believe if it's not completely seamless, it will be in the near future. Yes, I would absolutely recommend starting out with Calico. I see a lot of people will start out with, I know like at Rancher, the current default anyway is Flannel. In my personal opinion, there's no reason to use Flannel anymore. People use Flannel for VXLAN. VXLAN is supported in Calico. So places like Azure that disallow BGP, Calico you can use everywhere. It's ubiquitous. It's definitely, in my opinion, the best choice to start with. And I would recommend reaching out and getting help early on in your journey, so you can kind of learn from some of our customer interactions that you've seen, like our customer slide. We've been working with large organizations on scaling their Kubernetes deployments, and so you can learn from you can benefit from all of our learnings from that experience and kind of accelerate your Kubernetes adoption. All right, back to the demo. So you can see we have a staged network policy, and we're currently allowing all of the traffic. Let's take a look at this. I want to kind of demonstrate to you a couple of different things. Let me do this a little bit differently. So we're doing this a little live. What I'm going to do. So we were just showing you is that you can give people access to a graphical user interface and easily get them started on creating policy for themselves. We've shown you that you can deploy workloads to your cluster, and we give you the visibility to look and see who's talking to who inside the cluster. We give you the visibility to drill in and see all the flows in your cluster. We give you the raw data, and we also could recommend to you a least privilege policy. We allow you to stage that policy so you can see what would this policy be doing. Would it be allowing, you can see everything's all green. There's no denied packets here. What would happen if I was to enforce it? If I wanted to, I could promote this stage policy to an enforced policy. You see, it's no longer staged. One of the workflows that we see a lot of people implement is that they will create these policies using our graphical user interface. And then what they will do is they will download them, and they will open them up and edit them as code, like I've just done. You can see here we've got a network policy. And you can see this is the YAML representation of the Calico network policy that you see depicted here in our user interface. And then you can commit that to Git. You can take that policy and you can plug that into your CI/CD pipeline. And when you deploy that policy, you can deploy it as a staged policy, let it hang out for a while, let it bake, and then you can promote it to an enforced policy. So that's great. So we've shown a couple of different ways that we can safely enable people to easily create policies and collaborate on policies. But what happens if somebody messes up? What happens if Sabo shows up on his first day at work and he applies this policy that drops DNS for the entire cluster? He bricks the cluster with some botched network policy. How do you protect against that? We want to enable teams to participate, John, but we also don't want to lose our jobs because we caused an outage by allowing teams that might not be prepared to manage. I don't know. They don't know all the ins and outs of network policy management. We also, our security team is worried about opening up access to our workloads from like known bad IP lists, things like that. This is where policy tiers come into play. So right now we have only a default tier applied. And what I'm going to show you now is that we can create a hierarchy based on the separation of duties, the separations of concerns, organizational structures, and we can enforce policy tier by tier by tier. And we can do that to make sure that the security team is going to make sure that they're going to apply policies in their tier. Then make sure that the platform team or the developers that are using the default tier, they're not going to open up our organization to risk. The compliance team is going to make sure that all the compliance controls to satisfy the compliance criteria for the workloads in this cluster. Maybe we're running HIPAA workloads. We've got like PHI, there's like personal health information that requires encryption. So we need to have policy that ensures that those workloads are always going over encrypted communications. Maybe we have PCI workloads. We have multi-tenant multiple security criteria all inside of this single cluster, and we need to make sure that like the PCI workloads only talk to the PCI workloads. You can enforce those in specific tiers, and you can control who can apply policy in a particular tier using RBAC. So if I'm in the dev and the development team, I'm not going to be able to apply policy to the compliance controls tier or the security teams tier or the platforms tier. So it gives you guardrails around policy enforcement. The security teams tier is going to be enforced first, then the compliance teams, and you can see that by this order. The order is from lowest to highest. So let me go ahead and apply this. I'll take a look at this. So we just applied our tiers. Come back over here to the GUI, and we can see that that as traffic comes into this cluster, it's going to be evaluated from top to bottom, left to right. And this is drag and drop. So if your organization has a different workflow that you want to implement to free up teams to manage, you can create different tiers that model your particular team's structure. If I come over here, I'm just going to go ahead and delete this tier or this policy for a second, and I'm going to come back over here and create some policy just to have some examples. Let's do this. Let's security team. Let's pass to the next tier. Let's apply. Let's say network policy. So I'm just going to apply some example network policies just to have something to look at as we work through this next part of our demo. Policy, security team. Let's see what else we got. Let's do the deny threat feed. Maybe our security team wants to make sure that all the workloads in our cluster aren't sending any connections outbound to bad IP lists. Our security team wants to ensure that they're maintaining this bad IP list of known malware command and control centers, and we want to make sure that for whatever reason, any application that is deployed into our clusters just never talks to any of those. Policy. And let's take a look at the platform team, and let's do the pass to the next tier, and then let's do kubectl apply myself network policy and platform team, and let's do allow cluster DNS, and let's do allow logging. All right, and then let's do this really quickly. You know what? I'm just going to apply more. Let's do it. All right. So we built out our policy dashboard. We built out our hierarchy. If we take a look, as traffic comes in, it's going to be evaluated from top to bottom, left to right. And you can see that we've got a policy here that applies to 22 endpoints. So this is a global policy. So our security team has said, hey, every workload that runs inside of this cluster, it applies globally to all the policies inside of the cluster. We're just going to deny any access to any endpoints that happen to match the threat feed that we're subscribing to. So workloads are not allowed to talk outbound to malware. We also have a compliance team that has enforced PCI compliance, a PCI compliance policy that's saying, hey, we want to make sure that only all of our PCI workloads are using service accounts. We have them labeled appropriately. If your workload is using a service account that has a label PCI equals true, you're only allowed to talk to workloads that also have the label PCI equals true. So it's a way to enforce one particular security control for the PCI family of rules. Let me just make this a little less busy. All right, and then you can see we've got this zone-based architecture deployed. We've got a DMZ, we've got a trusted zone, and then we have a restricted zone. And you can see right here in the restricted zone, everything is allowed. And what I wanted to do is to kind of demonstrate to you the functionality of the stage network policy. So you can see the restricted zone, everything's allowed, nothing's being denied. And so what I'm going to show you is that I'm going to change the rules. So we've got, this applies to the storefront namespace, and this is also, this applies to all the workloads inside of the firewall zone, the restricted zone. So if I came in and I just, I don't know, denied all inbound access to all the workloads inside of the restricted zone, and I was to stage that change, I can see what would happen to the connectivity inside of the restricted zone. Let me find, down here we go. And in just a second, we're going to see how the stage policy changes, but the enforce policy will remain showing all allowed. So there we go, you can see. So as we make changes, either programmatically via CI/CD or using my user account inside of the Calico Enterprise UI, we can stage the policies before we enforce them. And I can look and see, hey, if I was to make that change, I would deny a bunch of traffic. This would cause an outage. And so I can know, hey, I don't want to enforce this policy. I want to, I'm not going to apply this policy because I would cause an issue for all of the workloads that are in the restricted zone. Let's see here, we're at 1:59, so we're coming up on the end of the hour. Let me take a quick look back here at the Q&A. Make sure that we look at this here. Can we visualize external DNS resolution for malware detection, threat intelligence? Yeah, one of the things that we collect, let me see here. If we come to the Discover board, you can see we capture all the audit logs. Actually, let me show you that. So as I was making changes here in the restricted zone, so I changed this, right? If you come down to the bottom, you can see I'm Tigera admin, and you can see the changes on a per policy. So you get a per policy change log, and you can actually see the diff. You can see that I moved that deny up above. And so you get like a bit of a git diff, a visual git diff of the changes I made. So you can see who made what change, what did they change, right? So we have audit capabilities. We also can see the changes across the entire cluster using our timeline. So we give you that visibility here. We also give you the raw data. We also record all of the DNS communication specifically inside of your cluster because we have some advanced threat detection capabilities. I think it's domain generation algorithms that malware uses to locate command and control centers. And we have a couple of different videos on that on our YouTube channel and some blogs as well. I encourage you to take a look at those. Can you show a dry run of a network policy? I believe that we kind of just did that with the staging just a moment ago. Suppose I am deploying this on any cloud tier. Will this cause any conflict with cloud network policies, for example, AWS or GCE platforms? So when you're managing network policy inside of your cluster, you're enforcing policy at the source. You have your enforcing policy at the source. So if you apply a policy that disallows or allows a workload inside of your cluster to communicate outbound, this is going to be the first stop, the first enforcement point before cloud-based enforcement or network policy controls would even come into play. And as you go a little further down the line, if you chose to define all your security controls using Calico, you could choose not to use a cloud-specific solution. You could say, hey, I have a multi-cloud deployment. I'm deploying in Azure. I'm deploying in AWS. I have to manage security groups in AWS. I have to manage network security groups in Azure, and it's become a pain. I could just enforce all my policies using Calico network policy and deploy them to both clouds and have the same network policies. And you could also, and that's one of the things that we see a lot of teams do. They will, especially, we talked a little bit about like creating templates for developers to get up and running. You can create templates for the security architecture of your cluster and apply that, the security team tier, the platform team tier. These could come baked into and deployed at install time prior to opening it up for collaboration into your cluster. So you know, everybody, your cluster is starting off from a known secure standpoint, and yeah, this solution can be applied across clouds and even on-prem. Can you please let us know what are network sets? Yeah, so network sets are lists of CIDRs. They can also be lists of DNS names. Let's take a look at a couple of these real quick. So here I've defined the public IP range, and I've got a list of CIDRs. I also have a lot of, specifically, we work with a lot of financial services teams, and one of the use cases that comes up is that, hey, we can no longer do business with a particular company, unfortunately, or a particular country, unfortunately. And so we need to apply that network policy. We need to ensure that we're not sending any traffic to these embargoed countries globally. DevOps team of 5, please make that happen. Well, if you have a policy that you can create a policy that applies to all flows that have the label embargo equals true, you just say, we're going to drop that communication. And then you apply that policy, and then you don't have to edit the policy. All you do is manage the CIDRs that are inside of this embargo country's network set. What it lets you do is create lists or sets of well-known CIDRs. You could think of this maybe like an object, an address object inside of a firewall, or an address group inside of a firewall. It's kind of the same thing, except that you can also have lists of DNS names. That's one of the Calico Enterprise segmentation capabilities we have, is we can also restrict outbound access to named resources like the dynamically generated names AWS gives you for RDS databases, or the C names, the vanity names you might assign to those names. All right, so we're 5 minutes past our time. I wanted to finish up with letting you know about some upcoming events. We have on August 27th, Getting Up with Calico on AKS, September 1st, Calico Network Policy on OpenShift, Calico Kate's network policies, an overview and comparison between Kate's Kubernetes network policies and Calico network policies, self-service network security again in Kubernetes. The next time I do this, I'm going to try to have a maybe like a CI/CD example that implements my opinionated automated workflow. And then we're going to do some Kubernetes network security intrusion detection mitigation in the EU time zone for you all who are in Europe or in the Far East. It will be a little earlier for you. And then getting up with Calico, AKS, and EKS. And then also, if you want to try out Calico Enterprise, if you go to tigera.io/trial, you can spin up a trial environment of Calico Enterprise, and then you can go through and you can see for yourself and try out the self-service building blocks that we demonstrated today. And you could see, how would I apply these in my own environment to further enable collaboration across the teams in your company, and just to free up developers to move faster, to free up ops teams to work on other things than just managing tickets, and just to generally get an idea of all of the goodness that comes with Calico Enterprise. Just want to say thank you very much for all of your time today. Thank you guys for joining. Thank you everyone for joining. I hope you found it interesting. We will email out the slides and also the link to the recording. Feel free to forward that on to your friends and coworkers. Thank you very much.